Good evening, everyone, and welcome back to another episode from the Azure Happy Hour series. My name is Rashmita, and I am the event planner for Microsoft Reactor India. I'm here today joined by our very own host, Reshmi, and our special guest speaker, Sandeep. But before we start the session, I would request you all to read our code of conduct. We are all here to learn together, so please be respectful of other people's views. Understanding of differences, be kind and considerate in the way you engage. The chat section is open throughout, and we do encourage you all to participate. Our speaker will answer all your questions during the session, so please feel free to drop all your questions in the chat section. With this, thank you all once again for joining us today. And sorry we are a little late. And but anyways, let me bring in Reshmi to start the session. Hey, Reshmi.
Hi Rashmita, good happy December.
Happy December, and
Yeah,
good to see you again.
thank you. And likewise, I'm super excited that this is probably going to be the last one for 2024, and we are going to be ending the 2024 series with a very special and a bang on performance by our chief guest today. So, thank you so much once again for having us
Thank
here,
you.
and I will quickly pick it up from here. So, everyone who is there with us on the call, good morning, good afternoon, good evening from wherever you are. Thank you so much for dialing in. And today we are really, really excited to talk about how exactly can you emphasize web worker architecture style into the services that you're building, right? And for that, we have our very own speaker, Sandeep Soni, joining us. So, Sandeep, we will be super happy to have a quick introduction of you before we jump
Hi,
into the
good evening,
topic.
everyone. Good morning from wherever you are. See, my name is Sandeep Soni. I'm a certified trainer. More than 28 plus years of experience now in the industry, working on multiple Microsoft technologies, right from VC++, Visual Basic, and then classic ASP, and then a lot of .NET I did in my career. Currently, I majorly focus on Microsoft Azure. I'm also a plural site elite trainer. I do their live training sessions across the globe in different parts of the world. I'm a solution architect, DevOps engineer. I think more than 16 odd certifications. I have all different Azure certifications. I'm also a regular corporate trainer with a lot of online presence with YouTube, having my own channel with 125,000 subscribers now. I think that is growing by probably now it is already 135 or so. So this is all about me, and yeah, I'm very happy to present my content to you and do a kind of transformation. So as
Yeah.
Rashmita has said,
Sandeep, before we go
I'm
there,
going to
can I just
yeah yeah
ask a
yeah
quick
yeah
question?
yeah please.
I am super interested in knowing like a one-liner on over the years of experience. How have you seen the technology develop, and what should be the focus for any new developer who's starting their career at this point of time on what they should be doing to become a big person in tech industry?
See, 30 years, right? Almost 3 decades. I've seen the industry. When I started the career, developers were like treated as gods. They had the power of doing everything, and they could probably convert anybody's requirement into a solution. And they were treated as the most important part of any IT team for producing the product. But everybody knows now things have drastically changed. How the chat GPT, how the generators, and you have got today Microsoft, I mean, OpenAI launching 401. So Open 401, and that's going to be like a miracle. We have, I mean, I was thinking all these years that AI would only probably be able to predict, and there will be one skill which nobody can take away from the humans, that is the skills, the specialization, the skillfulness with which we perform the task. But the generators are now making the whole thing different. So what was only predictor has now become generator. So the creativity aspect is also kind of stolen from human beings today by AI, or is being stolen from human beings to AI, and we have to now start competing with machine. We're not competing with each other, we are competing with machine. We have to outsmart machine today. Developers definitely are going to become more and more productive. You will see that we are not going to concentrate on small issues like syntax and stuff. We want to produce code very fast nowadays. Use something like GitHub Copilot, Copilot Studio, and so many copilots which Microsoft is giving. Yes, definitely it is going to be a challenging thing to a developer to continue in the industry. But what I also notice is, see, my parents, I give them a mobile. They find it difficult to use. I use mobile like a mobile. But then my next generation, they're so young and they know probably features of mobile more than me. So as the technology is evolving, the humans are also evolving. The humanity overall, the community overall is also evolving. So the generation to come will definitely have to put efforts in the direction where they adapt technology and then they add more value to that. And that's what is going to happen in the coming days.
That makes total sense, and thank you so much, Sandeep, for giving like a super insightful experience. I have one more request for you. You mentioned you have a good amount of followers, so I'm hoping some of your followers will jump into Azure Happy Hours as well. But that is
Yeah,
just a side
definitely. It will be my
note.
pleasure. We have
Awesome.
actually
Over to
done
you.
good
Let's.
promotion of this particular session to our followers also. So some of them
That's good
probably
to
are
know.
listening to this session as well.
I'm hoping to see more active interaction in the chat as well to everyone who has joined us. So
Yeah,
thank you so much once again, and over to you. We can jump into the topic.
thank you. Thank you. So guys, as the title of this particular session says, we are going to build and deploy an application more focused on specifically web worker architecture. You might have heard a lot about microservices architecture in the industry. And this is something before that, or I can say with that, but a smaller sized application. So before I actually get into what is a web worker architecture, there are certain important Azure services which we are going to make use of. I would like to take you through those small list of services, how the cloud has made the difference in the entire community. That's what you are actually going to know. See, before we used something like app services, today we are using, right, for our hosting of web applications. We are going to use Azure app services. But otherwise, what do we need? Prior to this Azure app services, I would need a machine, which can be a physical machine, which can be a virtual machine. And into these machines, we have to probably install all the dependencies required for our applications to work. For imagine, now I have a website to be hosted. That's a requirement. So if I need to have a website, definitely it needs the application which we have developed. But for that application to work, it needs a runtime in which it was developed. Maybe .NET runtime, maybe Java runtime, maybe Python runtime, maybe Node.js runtime, or any other runtime which has been used for development of the application, maybe Go language or Ruby on Rails. That runtime has to be present. But just that runtime is not sufficient. You also need to have something like a web server, and the web server and the runtime integration is also important. The web server should be able to receive the request, give it to that .NET runtime or Java runtime, which can execute the request, and through that execute our custom code which we have written. And then of course, as you have developed the application on maybe .NET and let's say Windows, you'll have to do maintenance of the operating system. You have to ensure that regular updates are installed, regular patches are taken care of. You have to regularly take backup of your application. You need to ensure security and so many aspects which we used to do. Now we don't need to do. When we are using Azure app services with few clicks of the buttons here and there in Azure kind of environment, you can create a complete platform. So Azure App Service is a PaaS, platform as a service, which is offered to us for deploying our application. And whatever I've said, the runtime, the web server, the dependencies, including the operating system and updates, are all taken care by the app service. We don't have to do that. So this layer is what we see, and everything beneath it is taken care by Microsoft Azure, or Azure App Service takes care of it. We just need to put our custom application and we are through. So Azure App Services are very simple and easy to deploy applications which we have built using various frameworks. So not just one language, we have got multiple languages support. With click of a button, we can switch from .NET Framework to .NET Core, or maybe .NET to Java altogether. If your application next version is coming in Python, switch the server to Python. So with click of a button or with some configuration change, you are able to make those changes applied into your environment. They are managed production. Why are we saying managed? Because everything is managed by the service in the background. The backups are taken care of. The scaling aspect, with click of a button, we are able to. You just say, I want 3 instances, mention number 3, and automatically 3 replicas are created. You don't have to do load balancing. I mean, everything is built in. You have got containerization and Docker support. The entire world is now moving to containers, working with Docker containers, creating applications which can probably be deployed into some kind of orchestrations. So if you are dealing with, let's say, large scale enterprise application, and if you have got plenty of services, you deploy each service, we generally call it as microservice, as a separate container and put them into something like AKS cluster. But if it is a small application and you don't want to have as big as AKS, very expensive and a lot of maintenance, you can do a containerization in your app service application itself. Extraordinary integration with DevOps, with CI/CD pipelines. You can click of a button, create the pipeline, and deploy the application. Lot of built-in templates. Let's say you want to have something like a content management system. There are ready-made templates which are present, WordPress, Joomla. There are ready-made templates which are present. You just need to select them and the entire environment is created. Yes, it is not going to provide serverless code. Azure App Service, you just need a app service plan. And as per the plan, you are going to be billed. And the plan can be changed at any point of time. You can scale, you can increase the configuration, you can decrease the configuration. Everything can be done on the fly. Net conclusion is, if you want to host a web application today, any part of the world, and if the organization has decided Azure, their best option would be to make use of Azure App Service. Only when they don't want to go for PaaS and they have some kind of legacy application. Let's say I have very old ASP application. I'm not even talking about ASP.NET, very old ASP application. Then I would go for something like virtual machine. I may not want to go for app service. Or if I want to use an environment which is out of support by Microsoft, I don't know what could be the reason, but if somebody wants to go for a very old legacy application deployment, then they would go for IaaS, that is virtual machines. If not, everybody's favorite has become Azure App Services. So Azure App Service is a fully managed platform for building, deploying, and scaling web applications, very specifically web applications. And of course, you can also put web APIs. It supports multiple languages, ideal for web apps, mobile backends, and RESTful API. Yes, that is one. That is the front end. But every application also requires some kind of backend where a lot of processing can happen and there is no direct user interaction. Maybe on some event, the action has to be performed. So these things we can do earlier using Windows services. But now we have got in cloud something called as function apps. So Azure function apps are a piece of code and it can be a function. In a function app, we can have multiple functions. You can have one function, you can have n number of functions added to the function app, and all these functions can be executed on need basis in the background. And you're going to have extraordinary benefits here also. Think of a function. Imagine you're Java programmer, you write main, and inside main you can do some coding. Or if you are .NET or C programmer also, you write main, and in that you can do some coding. Exactly like that. One function is what is function app all about. And in that function app, multiple functions can be hosted, giving you the advantage of writing independent logic to be triggered on different kind of conditions. Now the beauty of function app is it is serverless, or at least it can be configured as a serverless consumption pricing tier. So you don't have to pay when you're not using it. You only pay for the function app if the function actually executes. Look at app service, look at virtual machines, look at AKS. The moment you have provisioned the infrastructure, from that moment the billing will start. Now your website doesn't have traffic. They don't care. The billing is going to continue because you have reserved some hardware for the application. In Microsoft infrastructure, you have reserved the hardware. Function apps are not like that. You can configure function app and put the code on the storage account, and only when the request comes, the function app can be loaded into the memory and they can consume processor. Only for the duration they are executing and the amount of memory and the processor they are using, they are going to be billed for that moment. No requests are coming, they are sleeping, there is no billing. So like that, function apps basically are popular in the category where they are majorly used as consumption pricing tier. We call it as serverless architecture. Yes, function apps are triggered with various events. It can be by way of setting a HTTP call. I can invoke a function app, posting a message into a queue, which can be a storage queue, which can be a service bus queue, which can be a topic, uploading a file into a container, storage container. You can trigger a function app. You can trigger a function app on creating a record in the table of a Cosmos DB database, and you can execute a function app now also on a table updated or record added in a SQL table. I mean, there are various events which can be the starting point for execution of the code in the function app. The trigger should happen and the code will execute. Then code portability, you can build your application on your local machine and simply push it into the cloud. Dynamic scaling, as I told you, if there are 100 users, you're paying for 100. If there are 10,000 users, function app will dynamically scale. You don't have to do anything. Automatic scaling will happen, and then according to the amount of memory, processor and data transfer which is happening, you're going to get billed. Very efficient cost wise. Extensive integration with many other services, especially in IoT devices. See, imagine now there are like 10,000 cameras in a jungle, and these 10,000 cameras are continuously capturing photographs, and these photographs are fed into a IoT hub, and from the IoT hub I want them to be sent to a function app where they can be processed. That's pretty much possible. So very highly scalable, and at lightning speed the code can execute. So yes, front end we are always going to build with app services, and back end we can have something like a function app for logic. The background processing can be done through a function app. Fantastic. So that's about compute aspect. Now we cannot live with just compute. Always we need to have data. We have got a program made up of instructions and data. Instructions are taken care of by app services or function app. What about data? Now data can be of three types. I can have structured data, unstructured data, partially structured data. When I say structured data, I'm talking about something like SQL Server, Oracle, MySQL, where we create tables, and between the tables we'll create relationships, and every table have a fixed schema. So every record has same type or similar kind of data. I can store information about all employees in an employee table. I can store all departments in a department table. And then I can create a join between department and employee with a common column, primary key, foreign key. That's what is structured data. So many SQL databases are there which can be used for structured data. Then we have got partially structured data, your CSV files, comma separated values, or Excel file, Excel sheet, or a XML file, XML document. All these are partially structured data. And then we have got unstructured data. Unstructured data can be like MP3 files, MP4, or JPG, PNG, Word, PDF, right? All these formats, which are neither structured nor partially structured. All others we categorize as unstructured data. So in Azure, we have got Azure Storage Account, which basically takes care of the partially structured data and unstructured data. These two things, if you want, you can make use of the storage account. Yes, it's a service which handles your data in 4 different forms. Again, storage service is further categorized as blob, blob storage, file storage, queue, and table storage. 4 sub-services in storage account service. Now, what is blob? Blob is binary large object. That's where we'll store all our unstructured data. In blob, we'll create a container. Think of container like a bucket. And in that container, we'll put all our files, which we call it as blob objects. And then we have got file storage, blob storage, file storage. In file storage also, we'll put files only. In blob storage, we'll put files. In blob file storage also, we'll put files. But file storage majorly are for those kind of applications which we are probably planning to do lift and shift from on-premise to cloud. So the application in on-premise was using a file share server. Now that file share server has to be substituted with something when my application moves to cloud. From the on-prem to cloud, it is going in VM. I don't want to make any changes. I still want to continue to use the file share, which is nothing but the file storage in Azure. So lift and shift legacy application, file share is the best. There are certain protocols which are supported by the file share and not supported by blob. But mind you, blob is anytime cheaper, much cheaper when compared to file storage. So if you want to do modern application development and you want to manage files, your choice should be to make use of the blob storage, not the file storage. But if you're doing legacy old application, then go for file storage. And third comes queue. If there are two applications and they have to talk to each other and they cannot directly communicate with each other for whatsoever reason, they would put a queue in between. The application 1 will post a message into the queue and the application 2 will retrieve the message from the queue. The queue of the storage account is very popular for these kind of asynchronous communication between applications. And then we have got table storage, where we are going to store key value pairs. Basically no SQL database. We are going to simple form an entity with multiple key value pairs, and that entity we can add it to a table storage. So 4 different types of storage in the storage account, which can manage up to 500 TB of data. You can just imagine up to 500 TB of data one storage account can manage. And like this, there are 200 storage accounts we can create in one subscription. So see the kind of scalability we are going to get over here. Huge amount of scalability. We can start with few KBs and we can go to terabytes of data in storage account. And it's pretty much durable. Why? We said the data is durable because storage is going to maintain 3 copies of our data. At any point of time, there will be 3 copies of our data. So that makes our content durable. Data redundancy. You can have data not just in one geographical region, you can actually replicate the data into multiple regions. So 3 copies, let us say, are in East US. I can have another 3 copies in West US, and like that we ensure very high availability. Strong security. Data is secure in transit and data is secure on rest. When the data is residing in data center of Microsoft, it is encrypted and saved. And even in transit, a TLS or SSL protocol is used, and that ensures that the data is encrypted and it is sent on the secured wire. So in transit and in persistent at rest, in both the places it is secured. Cost optimization. You only pay for the amount of data you are storing. And of course, some transaction cost. You don't pay for, let us say your requirement is 100 MB of data. You don't have to upfront buy 1 TB or 1 GB. You only buy, or you don't even buy, you keep storing, and as you're storing, your charges are going to apply. Yeah, there are different access tiers, don't want to get into those details, but that can again be converted from hot to cool, cool to cold. I mean, hot to cold, cold to cool, and then you can have archive tier, which is very, very, very cheap in terms of storage. Durability I discussed, and you can transfer data from one place to another place. From on-prem to cloud, you can transfer data through storage. From one place, one storage to another storage, you can transfer your data. Multiple places you can transfer your data, and there are different ways of transferring again. A very vast subject to be discussed much in detail on need basis, but data is managed by storage in Azure. And I told you already, the structured data is taken care of by SQL database. So, and it has got all its benefit. High availability, 24 by 7, your data continuous backup is being taken in background. Anytime you can have point in time restore concept. You have got elastic pool to save the cost. Multiple databases can be pulled together, and you can make use of the compute power to the maximum extent. You can scale. Nowadays you have got serverless feature implemented in SQL databases also. You can optimize the cost as per the need. Multiple deployment options. Again, you have got different types of SQL databases which are present. You have got Azure SQL database, you have got MySQL, you have got Ingress. Multiple such databases are present. And beauty is you can do performance tuning. Automatic statistics will be provided. This query is little low in performance. This query is having this particular index requirement, which can probably improve the performance on a particular table. Like this, you can do performance tuning through the portal. Administrators get this as a very big advantage. And like this, many more advantages are provided in database provisioning in Azure. Basically, they categorize this as database as a service because of its vastness. Database as a service itself, we can call it. So these are different services which we use. Now coming to the main topic of today, what is web queue worker architecture? Now imagine I want to build an application, a
Sandeep, sorry,
web-based
just
application.
one question before we go to the architecture. So the three services that we saw right now, if you could just quickly tell the users how long would it take to spin up these, and maybe then we can jump to all of them.
See, if you want to spin up Azure App Services, 2 to 3 minutes. Function app, same story, 2 to 3 minutes. Right? Storage and SQL database, one time you spin up and you keep uploading the data. So
And
none
do
of
we
these
have any requirement that all of them have to belong to the same region?
not necessary. That's the beauty thing. Not necessary that they should belong to the same region. These are all PaaS services. So you can provision in any region and consume from any other region. Obviously, when we put all of them at one place, for example, it would make no sense for me to put, let's say, web server in East and function app, which is going to run in the background in West. There will be too much of latency. So I'll preferably keep all the related contents or aspects of the application in one region. but you can definitely keep them all in different regions and still transparently they'll talk to each other. Performance will be low, latency will be high.
Makes sense. Yeah.
Okay. Any other question, guys? Feel free to post your question in the chat, so that Rashmita can probably interfere me
Yeah.
and I will be able to answer because my eyes are not on the chat. So I would
No,
request
no, no
Rashmita.
worries. So whenever there are questions, I will take a break in between your slides. Like whenever we feel there is a good pause, and I can fire the questions. But folks who are watching, please feel free to share your questions because we will get the speaker to answer all of them while in the call itself.
Fantastic. Thank you. So coming to the main topic. So one thing we are very clear now. Cloud has been there for more than decade now and has penetrated so much into our blood that industry cannot exist without cloud platforms today. Now, one big benefit which cloud platforms have given to the community or to the especially developers is a broad mindset. We are able to leverage all the cloud features and build applications which probably we were not even thinking of few years back. So keeping all that story aside, what is web queue worker architecture? See, in a normal scenario, you might have a browser and a web server. From browser, a request will be sent to the web server, and web server is going to create one thread. In that thread, the entire request will execute. Maybe in that thread, only the code will be fetching data from hard disk, reading from database, calling some third-party APIs, getting data, building a pure HTML page out of it, and rendering it to the browser. In the browser, we see the content. We again submit the request. Again, processing happens. Similar kind of repetition. Same thing will go back to the browser. So this circle. Now in this, definitely the more processing we are doing in a web-based application, the more time it is going to take. And more the time it is taking, the experience with the user is not going to be so nice. We want quick result. I click of a button, I should less than 1 second get the response. That is what is the demand nowadays. I click and I should not even feel that a request has gone to server and come back. Everything should happen so fast. Certain things are not in our control. If you have to do a lot of processing over here, obviously it is going to take time. So what web queue worker architecture does is it splits the job between the web front end and the worker process in the background. We'll have a web which is going to receive the request, execute and produce the output. And then there will be a worker which will do certain things in the background. At least those things which the user is not immediately going to get impacted with. We would do them in the worker process, not in the main front end. By delegating some of the tasks from web front end to the worker, the advantage is we are able to execute the front end application faster. Task has been delegated, right? So obviously the task to be performed here will reduce, and that can be done over here. But there's a challenge here. How will the front end and the back end here is the worker process, how will they communicate with each other? That's where I'm going to bring a asynchronous communication, that is queue. So this is going to create a message and post that message into the queue. And upon receiving a message into the queue will tell the worker to pick up the message and execute the code in response to that. Yes, this is how the front end will delegate some of its tasks to the worker, and worker, if needed, would then talk to the database. Yes, definitely web application can also persist data in the database. Worker will get a message from the queue, but in message it can have some ID. Based on that, it can get larger volume of data from the database. And obviously some data, instead of getting it from the database every time, will put it in the cache, which is closer to the worker or to the web front end. Both web front end and worker can consume data from the cache rather than every time going to the database. And there can be some kind of static content. Instead of putting the static content in different parts of the world, I mean, rendering the static content to different parts of the world from one single location, we will use CDN, Content Delivery Network, which are basically different edge servers which are created across the globe, which are again doing caching of your content. For example, your CSS files or JavaScript files or static HTML files. Rather than every time executing, producing, and rendering, we can put them in CDN, and through CDN itself, we can directly render it into the client machine. They'll be faster because the CDN will be closer to your location of the client. There can be identity provider which can take care of the authentication. So net, you see a lot of things are coming into the picture, but majorly it's a front end queue worker. Rest all are need basis. On need basis, you add those services. So this is how web queue worker architectural style is. Yes, some key benefits. You have web tier, you have queue, you have worker tier. You are decoupling because of the asynchronous communication. Web tier doesn't have to wait for the worker tier to complete and then proceed. Asynchronous communication can happen. And because lot of the tasks via queue can be delegated to worker, web tier will automatically scale itself. It doesn't have to do every small thing. Lot of things it is delegating, and maybe you can have multiple instances of worker tier which are executing to process multiple messages into the queue. Imagine worker web is generating 1,000 messages in a second, but worker is only able to handle 100 messages in a second. Well, how will you deal with this situation? At one point of time, the queue will get filled up and it will overflow. So you run 10 or 12 instances of worker. So like that, you can scale them. So scalability can be achieved. And of course, because there is a reliable queue, nothing is going to be lost. Everything is going to stay here before it gets actually delivered to the worker tier. So these are the key benefits, and not mentioned there, but extraordinary user experience. Users will get response very fast. That's the main advantage of the web queue worker architecture. So
Sandeep, before we go to the next slide, there is one interesting question which possibly can be attended now. So we have Prabhakar and Arul in the chat. They are asking, instead of queue, shared memory or pipeline or message queues or PubSub interfaces can be used. May I know why specifically we are using queue?
queue is again one form of PubSub, publisher sub. I mean, queue, see, again, there are different types of patterns which we can follow. If it is one-to-one communication, right, for the message, if there is only one consumer, then you can simply go for a queue. But instead, if you are going for something like one message, multiple you consumers, then you should go for something like a PubSub model. So both, whether it is queue or publisher subscriber, which is nothing but a topic and subscriber, we call it, are implemented by the storage account. So basically, it's a further categorization of the same thing. You go more deeper on the basis of
Basically, we
your
are
requirement.
saying queue is a generic term you're using here.
Generic term we are using, exactly. So need basis, we'll have to decide either a simple queue or a topic with the subscriber can be used. So you may not use storage queue. You might sometimes go for something like service bus queue. So that is implementation details. Here we are talking about general architecture level.
Got it. Thank you. I think we can start.
Yeah. So if you look at the same diagram, and if you want to implement in Azure, the web is nothing but app services web app. The worker is a function app. The caching can be done by Redis cache. You can use SQL Server for structured data. And if you want to have large scale unstructured data, JSON data, Then you can go for Cosmos DB. You can have blob storage for all your static content, and the content can be delivered via CDN to the consumer. And the queue is nothing but one part of storage queue, or there is another service, as I said, service bus queue, which can be used for implementation. So like this, there are different services. The architectural style is mapped to different Azure services. So all this theory looks good, but unless I show it to you practically, it would not make much sense. So what I'll do is here switch to my Visual Studio. I've already developed the project. This is the web part, and this is the function. And to share certain things between these two, I've got a class library. So here I can show you the pieces of code little later, but first I will run the web application. After the web application is executed, I want to actually run the function app also. So this is my web application. I can delete some old data. This is some garbage. Don't worry about it. Fresh application would be something like this, where we are trying to capture employee details. So when I create a new record, I want to capture employee name, employee salary, maybe some file I want to upload, random some file. Supposed to be some image of the person, imagine, and upload. Now, my requirement is the file which we are, the data which we have put here, we should be able to save that in the database. So this should all go into database. The file which I have uploaded, I want to go to the storage account. This is the URL of the storage account which I have updated in the database. Now something important is this images which we are uploading can be of different sizes, different resolutions. We will not be able to show them consistently on our website. So the requirement is from this particular image, we should be able to create a thumbnail, and thumbnail should be stored in the storage account, and the URL of the thumbnail should be saved in the database. So right now there is no thumbnail. See, thumbnail has to be created. Now the code for storing this into a storage account and database will hardly take time, no time. But to create a thumbnail, it might be a time-taking process. So thumbnail creation, or maybe some watermark creation, or some kind of processing we want to do on that image which is uploaded, we can do that in the worker process. And that worker process is nothing but a function app. So this is a function app which I have developed in C#. Now that function app is going to start in the background. The function app which runs in the background would be responsible for taking the message. What happened here is this particular application, web app, has created a record in the table, has uploaded an image in the blob storage, blob container, and posted a message into a queue. Three things it did. Because a message is posted into the queue, the function app is now going to pick up that particular message. And that message will be used for retrieving the blob from the storage account, using which a thumbnail will be created. Thumbnail will be uploaded into the storage, and the updated URL will be saved in the database. So I'm launching the function app now. The function app is in execution. It should immediately pick up the message. Queue trigger. This particular function app is going to execute upon a message in the queue. And once that function is triggered, it will show some log over here. Maybe it's taking some time. Let's, in the meantime, look at how the services are in portal.
Maybe we can also try adding one more user into the database.
We want to have one more message.
Yeah, why not? One employee does not do the
One
whole
should
job.
come actually. Even one should come. So we'll actually, if you get an error, it's good. I can tell you how to debug. So we'll go and verify first if there is a message in the storage queue. Oh, what's happening, you know? There's a function app which is already deployed and that's catching up the message. In cloud, there is a message which has been, okay. So there is a function app here which I'll have to stop first. This is picking up the message. So we have two function apps. One I'm running locally and the other is running already in the cloud. I have published it to save time. And probably that is picking up the message. So I'll stop this for a while. Right, so this function app is no more running. So this should be able to consume the next message, which is posted into the queue. See? And we should get the image. This is the thumbnail of the original image. This is the original image actually, which I did not display intentionally. For your benefit, I am showing you the URL. I could have definitely put an image tag and shown exactly like this. So this is the original image, which is bigger in size. And the thumbnail of that is what is this. So this is perfect example of web worker, the web and the worker, and the code is shared through this particular library here. Now, this I have published to an app service. The web application I have published to the app service. So let me show you the components in cloud now once. We'll start with app service first. So we'll go to app service. Here is the app service which I have built, into which I'm deploying my application. And how to deploy? As simple as right click, publish. I created a web publish profile. and publish it. That's it. Hitting a button will publish the entire application into cloud. Second thing, application has to post messages into the queue. So I've created a storage account. There is a spelling mistake here. And once we have committed a mistake, we cannot, I realized much later, in Azure, we can't change names. I have to delete and recreate. So only for demos, I left it, but that's something really bad. So here you see EMP images is the container into which the images are uploaded. The first one and the thumbnail, second one and the thumbnail. And then we have got queue. Here itself, we have the queue. I've created a thumbnail queue into which I'm going to post a message. And from this queue only, the function app is going to pick up the message. The function app will pick up the message. The function app has one function which I have written. Data is getting persistent. So a lot of components. I know this session won't be sufficient for you to actually understand the code and do everything. So fortunately, what I could do is, if you can share the URL in the chat.
It's already shared.
Shared? Okay. So guys, you can download the entire project here. And there is a file here, step-by-step guide to build the project. I have documented everything in a Word document. I've given all the steps on how you can achieve this. You just follow this document, but you don't have to build also. You have to just follow the document, map it to the code, which is also provided over here in the main branch itself. So you can clone this entire project to your directory. After you clone, follow that Word document, step-by-step guide, and you'll see that complete code is present here on how to build this particular application. So in the function app, the major components, I'll show you first the major components. In the controller, you have got create, when I create an employee, and the file is uploaded, form file. And you see, I have created a function called as upload image, which I'll show you. And there's a function called as post message to queue. Upload is here. It's uploading the file into a blob and posting a message into a queue. When you're posting the message into a queue, and if it is an object, like here I'm taking an object of type blob information, in which I'm putting employee ID and the URL of the image which is uploaded into the storage account. I have to convert the object into base 64 format and then post that as a message into queue. Trying to post without converting to base 64 would be a blunder. At the time of receiving, you will get exception. Here you will not get error, but you will get exception at the time of receiving it. So this is the main three important components: post message, upload image, and the create button. This is the web application part. Yeah, definitely you have to also focus on app settings. Here I have given database. This is referring to right now my storage account. Definitely it's a bad practice to put the key in the app settings like this. Ideally, I should have actually used here a simulator, a local simulator of storage account, and this we should overwrite in the configuration of the app service. Now, where do we overwrite these things? You go to the app service, and in the app service we have environment variables. So here in the connection string, I've given DB context, and here this is not relevant, only DB context. Actually, here I should add storage account, but because the storage account is not okay, storage account is also ideally we should add that also into our app service. In the connection string section, I need to, but because I have directly used the cloud storage, I have not used the simulator. I didn't want to overwrite. Ideally, we should. Here, this should be replaced with a local simulator, and the one in cloud should use the actual storage account. This is bad. This is definitely bad. But make that change. And then I have next function app. In function app, I wrote a function which is going to trigger, and as soon as it triggers, it will read from this container the blob and will upload the thumbnail into this blob. And there's a code here for generating the thumbnail. I've used SK Bitmap, which is a open source for my creating or working with images by Google on all platforms. So SK Bitmap has been used, and basically we are converting input stream to output stream, and that output stream is connected to the thumbnail, and we are updating the data in the database. So you will have to leisurely go through all these components. Whatever is there in local settings here in Azure, we are updated using the function app, same environment variables. Right here, I've added Azure Web Job Storage, SQL connection string, right, and the DB context. So these are the components, and then of course you have storage account and you have got the SQL database, which are being used by the two applications. So look at the configuration file. You'll have to make the changes accordingly. You have the steps detailed drafted in case you want to, and of course you have the opportunity to come back to me in case you have any questions, and we can discuss at any time you feel. So
this is a really good presentation, Sandeep. Thank you so much for that. One last question before we sign off, just because I have some personal bias over there. Have you considered using static web apps instead of web apps, because it already has an inbuilt connection with functions, with database and all that, and it also segregates the.
You're talking about the storage account static web apps?
No, not static sites. So in Azure, you also have this application. In the app service, there is a static access.
No, I have not used that feature.
Okay. I mean, I was a PM for static web apps before, so
sorry.
Yeah, I used to be a PM for static web apps before, so I have a personal bias for that. That's why I thought I would just check with you if you have used it. Maybe you can try that and let. Yeah, maybe you can try and let the audience know on that, because the process of like having the whole web worker queue that you explained right now, it's already happening behind the scenes, and static web apps also lets you do a serverless development. So it kind of like gives you a good picture of how a small scale company can start off by testing the grounds, and later on maybe you feel like you need to scale up and ramp up, you need to have a dedicated server, you can always go to web apps. So I mean, just a suggestion, maybe you can try that and you can let your audience know.
I think I should definitely work on that and probably come back again with a detailed session on that.
That would be really good. So thank you so much once again, Sandeep. We are a little over time, but this has been really interesting and kept the audience up on toe. Before we leave, I will like to just take a quick call out. Sandeep's profile and social handle has been shared in the chat. Feel free to reach out to Sandeep or reach out to me if you have more topics, interesting topics that you would like to hear in Azure Happy Hours. And before we finally sign off, there is a quick survey which we would like to do to understand how you like the show, how you would like us to keep you engaged further. So please take a quick minute and thank you so much once again. Hope you all have a great 2024 end and a happy new year for 2025. Talk to you all very soon. Stay in touch. Bye bye.
Bye bye. Take care.